Hey Calc BC, today we are going to be learning lesson 6.2, geometric series, the nth term test, and telescoping series. These are three fairly straightforward ideas that will help us get into the groove of series. This is all from College Board's Unit 10, so you can see lessons 2 and lessons 3 from College Board talk about geometric series and the nth term test. That's what we're going to be focusing on for the most part today. And you can see here's more specifics about working with geometric series. A geometric series is a series with a constant ratio between successive terms. We talked about that with sequences back in the first lesson of our unit. And then in the intro worksheet for this lesson, you saw some more details about geometric series. And then the nth term test means is a test for divergence, and I'll show you what that means when we get there. So that's just a little bit of a preview. Let's switch over to the notes. All right, so here we have 6.2. Again, we're talking about geometric series, nth term test, and the telescoping series. So the first thing I want to say is that attached on Schoology is this chart, which we're going to need throughout this entire unit. This has really just almost all of the tests that we're going to be using either to show convergence of divergence of a series. And we're going to go over a couple of these today, but this chart will get you ready for the whole rest of the unit. So if you could print it out or at least have it saved somewhere on your computer, that's going to be great. And we're really going to be mostly looking at page 1. I know the file has a couple extra pages. Page 1 is really what we are most interested in right now. So if you're going to print it out, you really only need page 1. So I'm going to reference this a little bit today, but mostly we're going to be looking at the notes. And so let's get started. So a geometric series is in the form, and you can see right here we have summation notation. You learned about this in Calculus AB, but what it means is that for every n from 1 all the way to infinity, so all of the positive integers, we're going to be one at a time plugging them in for n, and then adding all of the terms together, right? It's a infinite sum in this case because it's going to infinity. And it's a geometric series when a is the first term and r is the common ratio, and r is raised to the n minus first power. The geometric series diverges if the absolute value of r is greater than or equal to 1, and if the absolute value of r is less than 1, it converges to the sum a over 1 minus r. That is all stuff that you saw in the preview worksheet. We're not going to do any more work proving that this is true, but it should make some sense if you think about what happens when you multiply by a small number that's less than 1 over and over versus what happens if you multiply by a number bigger than 1. It's going to grow without bound. So that's what we're going to be using today. So let's take a look. The first couple examples are straight from that practice worksheet that you did previous to this, the intro worksheet. But we're going to write it now using summation notation. So we are going to determine whether these series converge or diverge using what we call the geometric series test. So what we have to do is try to make this look like this. So we need to figure out what is a, what is r, and this exponent on the r needs to be n minus 1. So for letter a, what I'm going to do is I'm going to rewrite this separating the n exponent term from the 3, which doesn't have that exponent of an n. But I'm going to make sure I rewrite the summation every time. So it's going to be from 1 to infinity, 3 times 1/2 to the n, right? And that's just our properties of exponents. I can pull the n out and of the fraction, and it would look like that. But now I have an n exponent instead of an n minus 1. So I'm going to pull an extra 1/2 out. So it'll look like this. And if I do 1/2 times 1/2 to the n minus 1, I get 1/2 to the n. So I'm allowed to separate that. I'm going to just do one extra step to combine the 3 and the 1/2. And now that we've manipulated this expression, it looks exactly like the formula that we want. So 3/2 is the a and 1/2 is the r. And since r is less than 1, the absolute value of r is less than 1, that means we converge. So I'm going to write absolute value of r is less than 1. and I'm going to use my 3 dots in a triangle shape to mean therefore. So that means therefore, our series converges, and it converges to what? We have to do a over 1 minus r. So it's going to be 3 halves over 1 minus 1 half, which is 3 halves over 1 half, or 3 halves times 2 over 1, which is going to be 3. So this series converges to 3. If I add together all of the terms from 1 to infinity, we're going to be approaching a sum of 3. Let's try the second one. So we have 3 halves to the n. There isn't a separate constant multiplied in here that doesn't already have that exponent of n, but our exponent's n, not n minus 1. So we are going to rewrite this once to show that we can pull out one of the 3 halves so that now the exponent is n minus 1. And that means our a is 3 halves, and our r is also 3 halves. Since we're multiplying by a number that's bigger than 1, that means this series diverges. It's not going to have a sum that we can calculate. It adds up to approaching infinity, okay? So there we go. Let's keep going. Next example, consider the geometric series from n equals 1 to infinity, summation of a sub n, where a sub n is greater than 0 for all n. So all of the a sub n's, all of the terms that we're adding together are positive. The first term of the series is 108, and the third term is 12. What is the value of the sum? So we're told that we have a geometric series. Remember, a geometric series means that we're multiplying by the same ratio every time, right? In the first question, that ratio was 1/2. In the second question, that ratio was 3 halves. So if we know the first term is 108, and we know the third term is 12, what is the r? What's our formula here? So what do we know? We know that we're going to be getting into the format of a times r to the n minus 1. And we know that the first term is 108, and that's what a is. We don't know r, but let's see. If our third term is 12, that means we should be able to plug in 3 for n, and our answer should be 12. Right? That should be the third term. So let's see if we can calculate this. So we got to do what? 12 divided by 108. Let me pull out my calculator here. Okay, so I just did 12 divided by 108. It ends up being 1/9. So I get r squared, right? 3 minus 1 is 2, equals 1/9. And so r is going to be 1/3, right? The square root of that. So I never even found the second term, but I know that if I take 108 and I multiply by a third, and then I multiply by a third again, I'm going to get the third term. So in this question, I know that a is 108 and r is 1/3, because a always means the first term, r means what we're multiplying by, the ratio, to get each of the next terms one at a time. So I can say that my actual summation is going to be equal to, as we know, for a geometric series, well, first of all, let me slow down here. The absolute value of r is less than 1, so we converge. So that means our sum is equal to a over 1 minus r. In this case, that's 108 over 1 minus a third, which is 108 over 2/3, which is 108 times 3 over 2, which is going to be equal to 162. So that's what this series sums to with its infinite number of terms. Okay, so that's how the geometric series test works. And you can see here's a little bit, this question was a little bit backwards, made you think a little bit. So if we look back at our chart of series tests, that's the second test on the list, the geometric series test. You can see the series has to be looking in this format, which is exactly what we have. And we know that it converges if absolute value of r is less than 1, and it diverges if absolute value of r is greater than or equal to 1. And there's an extra comment. If it converges, here's the sum, right? That's exactly what we just talked about. So let's now look at the nth term test for divergent. The nth term test says that if the limit as n approaches infinity of the terms does not equal 0, then the series diverges. So this is where we really have to keep track of the difference between sequence versus series. Sequence just means, the list of the terms, whereas series means that we're adding each of them together to figure out what the sum of all the terms are. And so the nth terms test says that if the sequence of the terms is not approaching 0, so the actual terms themselves, like we did in lesson 1 from this unit, if those terms aren't approaching 0, then the series has to diverge. Because if they're approaching any other number than 0, the series can't be like kind of dropping off and kind of like getting closer and closer to a specific number. Let's say 5, right? If the sequence of terms are not approaching 0 and we keep adding them together, there's no way that we'll be able to like approach a limit of 5 if we keep adding 2 over and over, plus 2 plus 2 plus 2 plus 2 or whatever. We're going to keep getting bigger and grow infinitely. We're not going to stop as we get close to 5 when we start adding these things together. Hopefully that makes sense. This does not say that the limit as n approaches infinity, a sub n equals, if it equals 0, then the series converges. This test can only be used to prove divergence. There are a lot of different ways that series can diverge. It's not just if the sequence does not approach 0, but that's one way to prove divergence. If the limit as n approaches infinity, a sub n equals 0, then this test doesn't tell us anything. We're going to need to use another test. And don't worry, we'll be learning lots of tests. But let me show you what I mean here. So in this question, we are going to be, what this means is summation of a whole bunch of these fractions together, increasing n by 1 every time, right? From 1 to infinity. Let's just take a look at those terms. So the sequence terms. And from our previous lesson, if we wanted to find out what we converge to or if we diverge, what we would do is we could set up a limit as n approaches infinity of that expression and say, okay, what does this do? Well, we know from Bobo, Bot, Neats, DC, both of these n's have a degree of 1, right? This is n to the first power, this is n to the first power. So that's eats DC. If the exponents are the same, we divide coefficients. So this is going to equal 2/3. So these, this sequence over time approaches 2/3. And think about what happens if you keep adding 2/3 to something over and over and over and over and over. Your number is going to keep growing forever, right? It doesn't slow down growing if you keep adding 2/3. So that does not equal 0. So therefore, and what we're typically going to be saying in this whole unit is we have to say by whatever test we're using. So in this case, by the nth term test, the series diverges. Okay. And now that is the first test on our chart. We have the nth term test. If the series looks like this test cannot be used for convergence. So we will never prove that a series converges using the nth term test, but it will diverge if the sequence does not equal 0. The limit of the sequence does not equal 0. If the terms don't approach 0, or if the limit fails to exist. This test is used for divergence only. The converse is false. We can't use it for convergence. Okay, let's try that a couple more times with a couple more examples. Okay, so this means factorial, right? So for example, if you had 5 exclamation point, it would mean 5 times 4 times 3 times 2 times 1. So we don't know necessarily what the n is. It's going to be increasing by 1 for every term, but we have n factorial over 2n factorial plus 1. I'm going to set this up as a limit again, just so that we can check And even though these are not polynomials with a degree, which is what we usually have when we use Bobobot needs TC, we can use Bobobot needs TC for this. Just think about the n factorial over n factorial. Both of those are going to be equivalent as the n goes up, and the plus one is really not going to matter. So the coefficients really control what this approach is. So it's going to be 1 over 2. And so this approach is 1/2. Again, this is not equal to 0. So we would say, therefore, by the nth term test, the series diverges. That's what it's like we're adding 1/2 over and over and over and over and over infinitely. That sum is gonna continue to grow. And let's check this next one. The limit as n approaches infinity of 3 to the n minus 2 over 3 to the n. On the top and on the bottom here, we have exponential expression. The variables in the exponent, but it's 3 to the n and 3 to the n. So once again, these are equivalent growth, right? They're going to grow at the same rate. So since it's 3 to the n and 3 to the n, if we divide those, we would be getting 1. So this is going to approach 1 as n gets bigger. The 2 is going to matter less and less. And once again, that does not equal 0, right? So therefore, by the nth term test, this series diverges. Okay, we have got one more thing to look at here, and this is not technically on the chart, but it is something that we want to look at. A series is called a telescoping series if you can collapse it to one term or to a few terms. If the series collapses to a finite sum, then it converges by what we call the telescoping series test. This is kind of like an aside. It's something that we do need to know, but since it doesn't have like fancy rules that are always true, we don't have it on our chart. I'll show you what I mean when we solve this. So we are going to determine whether the following series converges or diverges using the telescoping series test. Why it's called telescoping is, think about if you have a telescope, one of the ones that like collapses. What we're going to see is that all of the terms in the middle collapse and just leave us with something at the beginning or something at the end. So let's take a look. What we're going to do here is just start to write out the first couple terms of this series. So let's think about what happens if I plug in 1 for n. We're going to end up with 1 over 2 plus 1 over, minus 1 over 2 plus 3. So that collectively is the first term. And I could do 1/3 minus 1/5, but I'm going to leave it separated for now, and you're going to see why in a second. What happens if I plug in 2 for n? I'm going to end up with 1/5 minus 1/7. If I plug in 3 for n, I'm going to get 1/7 minus 1/9. If I plug in 4 for n, I'm going to get 1/9 minus 1/11. And you might be able to see by now what's going to happen here. The second term in the first term, the second fraction in the first term and the first fraction in the second term will cancel out. So these go together, these pair up, etc. Every fraction is going to have a pair that cancels out with it, leaving us just with 1/3. So that is the sum, right? Because we are summing to infinity. So every single fraction is going to have a pair to cancel out with. And so we would say that by the telescoping series test, this series converges to 1/3. All right, so there you go. A little bit of a walkthrough through some of the first convergence tests. So thanks for watching. Have a great rest of the day. Let me know if you have any questions.